Right now, at this very moment, as you settle into your comfortable space, imagine standing on the edge of time itself. You're about to witness something that happened 66 million years ago, a single day that changed everything. A day when giants walked the earth for the very last time, when the sky caught fire, and when the world as it had been for over 160 million years simply welcome to Sleep About Science. Tonight, wherever you are in the world, whether you're tucked under blankets in London, watching the stars from Sydney, finding a quiet moment in Sao Paulo, or listening from a cozy corner in Cairo Mel, we're traveling back to explore the most catastrophic day in Earth's history, the last day of the dinosaurs. And if you drift off to sleep while listening, that's perfectly wonderful. In fact, as we journey through this story of endings and beginnings, letting your mind wander and rest is exactly what this space is for. Before we begin our journey through deep time, please make yourself comfortable. Adjust your pillows, pull your blanket up to just the right height, and let your breathing slow and deepen. Feel the weight of your body settling into your bed, the softness of your sheets against your skin, the gentle rhythm of air moving in and out of your lungs. And remember, this is educational content, not medical advice. If you haven't subscribed yet, you might want to, so you never miss these gentle journeys into the deepest mysteries of science. Now, close your eyes and let me take you back, way, way back, to a Tuesday with Destells. If scientists have actually calculated, it was likely a Tuesday 66 million years ago. The sun is rising on what will become known as the Cretaceous Paleogene boundary, though of course, no creature alive on that morning could possibly know they're living through the end of an era. To truly understand this day, we need to understand the world it's about to transform forever. Picture this ancient earth and let yourself really see it, feel it, breathe it in. It's a planet that would seem both familiar and utterly alien to your modern eyes. The basic geography would confuse you, me, Sue. The continents are in the wrong places, drifting slowly like massive, patient ships toward their modern positions. The Atlantic Ocean is narrower than it is today, perhaps half its current width. The Rocky Mountains are still actively growing, their peaks sharper and more dramatic than the weathered ranges you might know. India is an island continent, still millions of years away from its collision with Asia that will create the Himalayan range. This is a greenhouse world, warmer than anything in human experience. There are no ice caps at either pole. Palm trees and ferns grow in Alaska, and forests stretch across Antarctica. The average global temperature is about 15 degrees Fahrenheit warmer than today, creating a planet where tropical and subtropical conditions extend nearly to the poles. The weather patterns are more extreme too. Massive hurricanes that would dwarf anything in recorded history regularly sweep across the warmer oceans, while monsoon seasons bring torrential rains that can last for months. The atmosphere itself is different. There's more carbon dioxide than in your modern world, perhaps twice as much, creating a natural greenhouse effect that maintains these balmy conditions. The oxygen content is also different, slightly lower than what you're breathing right now, which has fascinating implications for the creatures that live in this ancient world. And what creatures they are? In what will one day be Montana, as the first light of this fateful Tuesday touches the landscape, a Triceratops matriarch raises her massive head from a stand of flowering magnolias. She's magnificent in a way that our modern world struggles to comprehend, 12 feet tall at the shoulder, 30 feet from nose to tail, with a skull that alone weighs nearly 2 tons. Her three horns, two long ones over her eyes and a shorter one on her nose, were not just weapons but complex communication devices, each one capable of subtle movements that convey meaning to other members of her species. Her frill, that great bony shield extending back from her skull, is decorated with scalloped edges and painted in patterns we can only imagine. Recent fossil discoveries suggest these frills may have been brightly colored, perhaps with seasonal variations, sexual dimorphism, or individual patterns as unique as fingerprints. This morning, her frill might be displaying the deep burgundy and gold of a mature female in good health, catching the early sunlight like a natural crown. She doesn't know she's one of the last of her kind. She doesn't know that in roughly 12 hours, everything she has ever known will be gone. Right now, she's simply focused on breakfast, using her powerful beak to slice through tough magnolia leaves with the efficiency of industrial shears. Each bite requires careful processing. She has no grinding teeth in the front of her mouth, so she must use the complex dental batteries in her cheeks to break down the fibrous plant material. Watch her for a moment, this gentle giant. Notice how she moves with surprising grace for a creature weighing as much as a large truck. Her massive legs, each foot bearing claws that could tear through tree trunks, step carefully around the delicate flowering plants at her feet. She's not clumsy or brutish, she's precise, deliberate, aware of her place in this ancient ecosystem. Nearby, hidden in the dappled shadows of primitive oak trees. Yes, oaks existed then, though they looked quite different from modern varieties. A small furry creature watches nervously. This little survivor, no bigger than a rat, but carrying the future of all mammalian life in her genes, has evolved exquisite caution. Her kind has spent the last 50 million years in the shadows of giants, coming out mainly at night, living on insects and seeds and the occasional abandoned egg. She's beautiful in her own way, this ancestral mammal. Her fur is dense and soft, providing insulation that the scaly skin of dinosaurs cannot match. Her eyes are large and dark, adapted for the twilight world in which her species thrives. Her paws are nimble, capable of grasping small objects with surprising dexterity. Her teeth are varied and complex, not the specialized dental batteries of herbivorous dinosaurs or the simple slashing teeth of carnivores, but a versatile toolkit capable of processing many different kinds of food. She twitches her whiskers, sensitive organs that can detect the slightest air currents and vibrations, and scurries to safety behind a fallen log. By day's end, her caution will have saved not just her life, but the future of all mammalian life on Earth, including your own distant lineage. Above them both, riding the warm thermal currents with effortless mastery, a Quetzalcoatlus soars on wings that span the width of a small airplane. This creature, part bird, part dragon, from our modern perspective, is one of the largest flying animals that has ever existed. Her wingspan stretches nearly 40 feet from tip to tip, and yet her entire body weighs only about 440 pounds, less than many modern birds of prey. This is engineering at its finest: hollow bones, air sacs throughout her body, and wings constructed like living sails. She's searching for her breakfast, with eyes sharper than any hawk's, capable of spotting prey from miles away. Her long, narrow skull houses a brain surprisingly large for a reptile, with expanded regions devoted to processing visual information and coordinating the complex muscle movements required for flight. She doesn't flap constantly like a bird. Instead, she soars like a living glider, riding the invisible rivers of rising air with the casual mastery of millions of years of evolution. The sky belongs to creatures like her. Pterosaurs have ruled the airspace for over 150 million years, diversifying into forms that filled every possible flying niche, from tiny sparrow-sized insect catchers to giants like Quetzalcoatlus that could cross continents on their massive wings. By sunset today, the sky will belong to no one. The age of pterosaurs will end as suddenly and completely as if someone had simply turned off the power that keeps them aloft. But let's pause here, in this moment of ordinary morning routine, and marvel at just how extraordinary ordinary can be. These creatures, the Triceratops methodically chewing her breakfast, the tiny mammal gathering seeds with nimble paws, the Quetzalcoatlus riding invisible rivers of air, the products of evolutionary processes so vast and intricate that they make our human civilizations seem like brief flickers of candlelight. Consider the depth of time that has created this scene. The Triceratops belongs to a lineage that stretches back over 200 million years. Her ancestors were small bipedal creatures that gradually evolved the quadrupedal stance, the bony frills, the complex social behaviors that define her kind. Every aspect of her anatomy tells a story millions of years in the making. Her three-horned face, which seems almost comical to us now, is actually a masterpiece of bioengineering. Those horns aren't just weapons, they're communication devices, display structures, and thermal regulators all rolled into one. The blood vessels running through them can dilate or constrict to help control her body temperature in this warm Cretaceous world. The muscles that control their movement are connected to complex facial expressions that other triceratops can read like an emotional language. Her frill contains a network of blood vessels that help her control her body temperature, but it's also reinforced with bony studs and spikes that make it an effective shield against predators. The patterns of bone growth in the frill can tell us about her age, her health, even the seasons she's lived through. This morning's frill might show the robust growth patterns of a creature in her prime, well fed and successful in the competitive world of Cretaceous herbivores. Her feet, each one the size of a dinner table, are marvels of weight distribution. The bones are arranged in natural arches that spread her massive weight efficiently across the ground. Her claws, though fearsome looking, are actually more like the hooves of modern large mammals designed for traction and stability rather than predation. Even her digestive system is a wonder of evolutionary engineering. Like modern elephants, she must process enormous quantities of plant matter to fuel her massive body. Her gut contains a complex ecosystem of bacteria and other microorganisms that help break down cellulose and other tough plant compounds. The fermentation process generates significant heat, part of the reason large dinosaurs could maintain their body temperature even in cooler conditions. And yet, for all their magnificent adaptations, for all their evolutionary success, spanning tens of millions of years, for all the ecological niches they've mastered, something is coming that no amount of evolution could have prepared them for. At this very moment, roughly 66 million years ago, somewhere high above the Yucatan Peninsula, in what will one day be Mexico, there's a visitor approaching from the deep cold of space. It's been traveling for perhaps millions of years, possibly much longer, a wanderer from the distant reaches of the solar system, or even from the asteroid belt between Mars and Jupiter. This visitor is an asteroid as a mountain of rock and metal and ice, about 6 miles wide, hurtling toward Earth at a speed of roughly 45,000 miles per hour. To our modern minds, accustomed to the speeds of cars and airplanes, this velocity is almost impossible to comprehend. It's traveling faster than any bullet ever fired, faster than the escape velocity needed to leave Earth's gravitational field, fast enough to cross the entire United States in about 6 minutes. To put that size in perspective, imagine every person living in Manhattan today standing shoulder to shoulder. Now stack that crowd of people into a cube. You'd need about 40 such cubes to equal the mass of this approaching asteroid. Or think of it this way, if you placed it in the center of London, it would stretch from the Tower of London to Hyde Park and rise higher than any skyscraper humans have ever constructed. But it's not just a simple ball of rock. This asteroid is a complex geological object with its own history spanning billions of years. Its surface is pocked with smaller craters from impacts with other space debris. Its interior contains a mixture of rock and metal, possibly including rare elements that are scarce on Earth's surface. Some parts of it may contain organic compounds, the basic building blocks of life, forged in the hearts of ancient stars and delivered across the cosmos. If you could somehow stand on its surface as it approaches Earth, which of course you couldn't survive, you might see a landscape as alien and wonderful as any planet. There would be cliffs and canyons carved by countless smaller impacts, fields of boulders held in place only by the asteroid's weak gravity, perhaps even deposits of ice in the permanently shadowed regions where sunlight has never fallen. But size and composition, as catastrophic as they are, aren't the only factors that will determine this object's destructive power. It's the speed that transforms this cosmic mountain into something unimaginably destructive. Traveling at 45,000 miles per hour, this asteroid carries kinetic energy equivalent to roughly 100 million hydrogen bombs, more destructive power than all the nuclear weapons ever built by humanity, multiplied by 1,000. To understand this kind of energy, imagine trying to stop a freight train traveling at full speed by standing in front of it. Now multiply that train's mass by 1,000,000 and its speed by 100. You're beginning to approach the kind of force that's about to strike our planet. The asteroid has been invisible to any Earth-bound observer for most of its approach, a dark speck against the black of space, perhaps visible only as a faint star that grows slightly brighter each night. Even if some hypothetical Cretaceous astronomer had been watching the skies with instruments as sophisticated as our own, the asteroid would have been nearly impossible to detect until its final approach. But now, on this particular Tuesday morning, it's close enough that if any creature had the right kind of eyes and knew where to look, they might see it as a moving point of light, like a very fast satellite crossing the pre-dawn sky. The Quetzalcoatlus, with her keen eyesight, adapted for spotting prey from great distances, might actually be capable of seeing it if she happened to look in the right direction at the right moment. But she doesn't. She's focused on the rivers and lakes below, searching for the fish and small aquatic creatures that make up much of her diet. Her brain, sophisticated as it is for a reptile, has no context for understanding what a bright moving star might mean. Even if she saw it, it would simply be another mystery in a world full of incomprehensible phenomena. The Triceratops continues her breakfast, completely unaware that death is approaching from above at cosmic speed. She's found a particularly lush grove of cycads, palm-like plants that have been successful on Earth for over 250 million years. These plants, with their tough fibrous fronds, require careful processing, and she's developed a technique for stripping away the less nutritious outer portions to get to the more digestible inner tissues. Her massive jaw muscles, some of the most powerful ever evolved, work rhythmically as she chews. Each bite requires the coordination of dozens of muscles, the precise alignment of her complex dental batteries, the careful positioning of her tongue to move food around her mouth. It's a process that has been refined over millions of years of evolution, and she performs it with unconscious mastery. The little mammal finds a particularly rich cache of seeds beneath a fallen log. These seeds, from an early flowering plant related to modern magnolias, are packed with nutrients and oils that will help sustain her through the challenges ahead. She doesn't know, of course, that she's gathering provisions for the end of the world, but her instinctive hoarding behavior, evolved over millions of years of living in a dangerous world, will serve her well in the catastrophe to come. Her tiny hands, each no bigger than a human thumb, work with surprising dexterity as she cracks open the tough seed cases. Her teeth, unlike the specialized dental batteries of dinosaurs, are generalized tools capable of processing many different types of food. This flexibility, the ability to eat almost anything organic, will be crucial to her survival in the transformed world that's coming. None of them can see what's coming, and perhaps that's for the best. If they could comprehend what's about to happen, the last peaceful moments of the Mesozoic era would be filled with terror instead of the simple, profound beauty of creatures going about their daily lives. But we can see it. In our minds, we can follow this mountain of rock and metal as it screams through the upper atmosphere, heating to incandescence from friction with the thin air. We can watch as it penetrates deeper and deeper into our planet's protective envelope, moving so fast that the air itself cannot get out of its way. The asteroid's surface begins to glow as atmospheric friction heats it to thousands of degrees, but it's moving so fast that there's no time for this heat to penetrate more than a few inches into its bulk. The vast majority of its mass remains cold and solid, a cosmic hammer about to strike an anvil made of stone and metal and living tissue. Let's travel, in our minds, to that moment of impact. It happens at exactly 11:47 a.m. local time, just off the coast of what will one day be the Yucatan Peninsula. The asteroid, traveling faster than anything these ancient creatures have ever experienced, faster than sound, faster than lightning, faster than thought itself, punches through the last few miles of atmosphere in a fraction of a second. The moment of impact is almost impossible to comprehend, even with all our modern understanding of physics and energy. Imagine trying to stop a bullet with tissue paper, except the bullet is a 6-mile wide mountain moving at cosmic speeds, and the tissue paper is the relatively thin crust of our planet. The asteroid doesn't slowly crash or gradually penetrate the Earth's surface. It simply disappears into the planet as if the solid rock were liquid, as if the laws of physics had suddenly changed. In that instant, to know less time than it takes you to blink, in less time than it takes a nerve impulse to travel from your brain to your hand, several catastrophic things happen simultaneously. each one capable of ending civilizations, each one contributing to the greatest mass extinction in Earth's history. First, the asteroid vaporizes completely. 6 miles of solid rock and metal, accumulated over billions of years in the cold of space, transformed in milliseconds from matter into energy, from a solid object into superheated gas and plasma, hotter than the surface of the sun. The temperature at the impact site rises to over 20,000 degrees Fahrenheit, hot enough to melt any known material, hot enough to break apart the very atoms that make up ordinary matter. Simultaneously, the Earth's crust at the impact site doesn't crack or break. It behaves like a liquid, flowing outward in massive waves, like the surface of a pond when you drop a stone, except these waves are made of molten rock and they're moving at supersonic speeds. The solid bedrock of the Yucatan Peninsula, formed over hundreds of millions of years, is liquefied and thrown outward in all directions. The crater begins forming immediately, growing outward and downward at speeds that defy comprehension. The Earth's crust, normally as solid and permanent as anything in our experience, flows like water under the unimaginable pressures generated by the impact. Within minutes, a wound in the planet's surface begins to open in a crater that will eventually span 120 miles from rim to rim and plunge 12 miles deep into the Earth's crust. To put this in perspective, imagine a crater large enough to swallow the entire state of Connecticut, deep enough that if you dropped Mount Everest into it, the peak would still be miles below the rim. This is not just a hole in the ground, it's a fundamental restructuring of the planet's surface, a geological event so violent that its effects will be visible for millions of years. But the crater itself is just the beginning of the catastrophe. The impact sends a shock wave through the solid earth, not through the air, but through the rock itself. This seismic wave travels at nearly 4 miles per second, carrying energy that makes our most powerful earthquakes seem like gentle tremors. The wave propagates through the planet's crust and mantle, shaking the entire North American continent like a bell struck with a cosmic hammer. Imagine the most powerful earthquake you can conceive of, then multiply its strength by 1,000. That's what every creature on the North American continent experiences within minutes of the impact. The ground doesn't just shake, it moves in ways that solid rock should never move, heaving up and down in waves dozens of feet high, opening cracks that swallow forests, whole toppling mountains that have stood for millions of years. Our Triceratops, peacefully eating her cycad fronds in Montana over 1,000 miles from the impact site, suddenly finds the ground beneath her massive feet moving like ocean waves in a hurricane. The sensation is beyond anything in her evolutionary experience. Her kind evolved on stable ground in a world where the earth itself was the one constant that could always be trusted. Trees that have stood for centuries topple around her like matchsticks. The very landscape writhes and cracks as if the planet is in pain. Massive boulders, some the size of houses, bounce and roll like pebbles. The cycad grove, where she was feeding moments ago, disappears into a crack that opens in the earth's surface and then snaps shut like a closing mouth. She trumpets in alarmless sound, like a ship's horn crossed with an elephant's bellow, a cry that carries for miles across the chaos, but her voice is lost in the rumbling, grinding, crashing symphony of a continent-sized earthquake. Her massive legs, perfectly designed for supporting her weight on stable ground, struggle to maintain balance as the earth beneath her moves in ways that solid matter should never move. But the seismic waves, devastating as they are, pale in comparison to what's happening above ground. The impact has launched millions upon millions of tons of vaporized rock directly upward in escape velocity, fast enough to leave Earth's atmosphere entirely and arc into the vacuum of space itself. This superheated material, traveling at speeds of several miles per second, rises through the atmosphere like a massive geyser of molten rock and superheated gas. Some of this material reaches altitudes of over 100 miles above the Earth's surface, higher than the space shuttles of your era ever traveled, high enough to see the curvature of the planet and the thin blue line of the atmosphere against the black of space. At these heights, the ejecta spreads out in all directions, forming a vast umbrella of molten debris that will soon begin its inevitable fall back to Earth. But as this material falls, something terrible and beautiful happens. Friction with the atmosphere heats the returning debris until it glows white hot, like millions of meteors, all falling simultaneously. Each fragment, from tiny droplets no bigger than raindrops to chunks the size of automobiles, becomes a blazing streak of light as it plunges through the increasingly thick atmosphere. The sky catches fire. Imagine standing outside on the clearest, darkest night you've ever experienced, when the Milky Way stretches from horizon to horizon and the stars seem close enough to touch. Now imagine that instead of a few dozen shooting stars per hour, the kind of meteor shower that might make you gasp with wonder, you're seeing millions of them simultaneously, all of them blazing across the sky in every direction like a cosmic fireworks display gone mad. The entire dome of the heavens becomes a seething mass of light and fire. Every square mile of sky contains hundreds of blazing meteors at any given moment. The light is so intense that it turns night into day across half the planet. The beauty is overwhelming and terrifying in equal measure, and display of celestial pyrotechnics that no creature in Earth's history has ever witnessed. But the celestial light show is not just spectacular burst, it's deadly beyond measure. The energy released by all this falling debris heats the atmosphere itself, not just the upper atmosphere, but the air that creatures breathe, the air that surrounds and sustains all terrestrial life. The temperature begins to rise and rise. Within hours of the impact, locations thousands of miles away from the crash site are experiencing air temperatures hot enough to ignite dry vegetation spontaneously. The very air becomes an oven, heated by the constant rain of glowing debris until breathing becomes difficult, then dangerous, then impossible for many creatures. Forests that have stood since before the first flowers bloom suddenly burst into flame. Not just a few trees here and there, but entire continental forest systems igniting simultaneously as if someone had poured gasoline across the landscape and struck a match. The Congo Basin burns. The vast temperate forests of North America erupt in flames that can be seen from space. Siberian woodlands that have never known fire suddenly become infernos. Even forests in Antarctica. Yes, Antarctica had lush temperate forests that naturally catch fire and burn with an intensity that turns the southern sky orange with smoke. This is not ordinary wildfire that burns along the ground and can be escaped by fleeing to water or open ground. This is thermal radiation from the heated atmosphere itself, inescapable and omnipresent turning the entire surface of the planet into a giant oven. Our little mammalian ancestor, the cautious one we met earlier, gathering seeds in the Montana dawn, makes a decision that will echo through 66 million years of evolutionary history. As the sky begins to glow ominously and the air grows uncomfortably warm, her deepest instincts, refined by 50 million years of living in a dangerous world, tell her to go underground. She doesn't understand what's happening. How could she? Nothing in her genetic memory, nothing in the experience of her species has prepared her for a catastrophe on this scale. But her ancestors survived countless smaller disasters by being cautious, by hiding, by waiting out danger in the safety of deep burrows. She disappears into her tunnel system, pulling dried grass and leaves over the entrance, sealing herself into a space that will remain relatively cool and safe while the world above burns. The soil around her burrow is an excellent insulator, protecting her from the wild temperature swings happening on the surface. Her small size means she needs less oxygen than larger creatures, and the air in her burrow remains breathable while the atmosphere above becomes a furnace. This simple decision ends to hide underground when danger threatens will save her lineage and eventually lead to every mammal alive today, including you and me. In the most profound sense, you exist because 66 million years ago, a small furry creature decided to take shelter when the world caught fire. The Quetzalcoatlus, master of the skies for her entire species' 70 million year reign, suddenly finds the air itself becoming her enemy. The heated atmosphere creates turbulence unlike anything her kind has ever encountered. The thermal updrafts that have carried her gracefully aloft for her entire life now buffet her massive wings uncontrollably, threatening to tear the delicate membranes that keep her airborne. The sky fills with smoke and glowing debris. The familiar landmarks she uses for navigation disappear beneath a shroud of ash and flame. The air currents she has learned to read like a language become chaotic and unpredictable. Temperature differentials that create the rising columns of warm air she depends on become extreme and dangerous. She struggles desperately to find a safe place to land as the world below her transforms into a sea of fire. Her keen eyes evolve to spot prey from miles away, now show her a landscape that seems to have been transported from the depths of hell. Every forest is burning, every grassland is ablaze, every familiar roosting site is engulfed in flames. Her massive wings, miraculous constructions of bone and membrane and muscle that have carried her across continents, begin to fail her as the superheated air damages the delicate tissues that make flight possible. The membrane between her wing fingers, thin as leather but strong as steel cable, starts to dry and crack in the heated atmosphere. Meanwhile, our Triceratops, still reeling from the massive earthquake that shook her world, looks up to see something that no herbivore in Earth's history has ever witnessed on the sky on fire. The entire dome of the heavens glows like the inside of a blast furnace. Millions of blazing meteors streak overhead like arrows shot by angry gods. Hot wind begins to blow from the south, carrying the scent of burning forests from thousands of miles away. The air itself seems to shimmer with heat, creating mirages and distortions that make the familiar landscape appear alien and threatening. Her thick hide evolved to protect her from predators and regulate temperature in the warm Cretaceous climate, begins to feel uncomfortably warm, then painfully hot. She seeks shade beneath a grove of primitive conifers, but even the shadows provide little relief from the ambient heat radiating down from the sky itself. She opens her mouth and pants like a dog, trying to cool herself by evaporating moisture from her mouth and throat. But the air she breathes is so hot that it provides no relief. But we're still in the first few hours of this catastrophic day. The immediate effects, the earthquake, the thermal pulse, the beginning of the global firestorm, are just the opening notes of a symphony of destruction that will play out over months and years. The worst is yet to come. Remember that massive crater in the Yucatan? It's not finished wreaking havoc. The impact has punched through the Earth's crust and into the mantle below, creating what geologists call impact melt, essentially lava created by the force of collision rather than by volcanic processes. This molten rock begins to flow outward from the crater like a sea of liquid stone, covering thousands of square miles in temperatures hot enough to vaporize anything in its path. But something else is happening that will have even more far-reaching consequences. The impact site, it turns out by the cruelest of coincidences, was particularly rich in sulfur-bearing rocks, ancient deposits of gypsum and anhydrite laid down by evaporating seas millions of years earlier. The collision has vaporized countless tons of these sulfur compounds and launched them into the stratosphere, to layer of atmosphere that sits above our weather, above our clouds, above everything familiar. These sulfur compounds begin to react with water vapor in the stratosphere, forming tiny droplets of sulfuric acid. Each droplet is microscopic, invisible to the naked eye, but collectively they begin to form a haze that starts to spread around the globe. The droplets are so small that they can remain suspended in the stratosphere for months or even years, and they have a particular property that will prove catastrophic for life on Earth. They reflect sunlight. At the same time, the massive fires now burning on every continent are pumping enormous quantities of smoke and ash into the atmosphere. Soot from burning forests in North America mixes with dust from the impact crater, ash from spontaneous vegetation fires, and those deadly sulfuric acid droplets in the stratosphere. A veil begins to form around the planet, a shroud of debris and chemicals and smoke that grows thicker and more opaque with each passing hour. As the afternoon progresses on that terrible Tuesday, creatures around the world begin to notice that the sun seems dimmer, not dimmed by ordinary clouds. This is different. The light itself seems filtered, muted, as if someone has placed a dirty window between Earth and the life-giving energy of our star. The thermal pulse from the falling debris is beginning to subside, but it's being replaced by something potentially even more deadly in gradual reduction in the amount of solar energy reaching Earth's surface. The planet's entire energy budget, the fundamental equation that has governed climate and weather for billions of years, is being altered in real time. Plants, of course, don't notice consciously, but they begin to respond physiologically within hours. Photosynthesis, the process that has fed life on Earth for over 2 billion years, the foundation of every food chain, the source of all the oxygen we breathe, becomes less and less efficient as less and less sunlight penetrates the growing atmospheric shroud. The flowering plants that have transformed Cretaceous landscapes, creating the first recognizably modern ecosystems, begin to slow their food production. The ferns that dinosaurs have browsed for over 100 million years start to curl their fronds and reduce their metabolic activity. The algae in the oceans that form the base of all marine food chains begin to die as sunlight fails to penetrate the water's surface. But plants are patient. They have evolved strategies for surviving temporary reductions in sunlight. They can slow their metabolism, drop their leaves, wait for better conditions in a kind of botanical hibernation. The creatures that depend on them have no such luxury. Most large dinosaurs are what biologists call high energy organisms. They require enormous amounts of food to fuel their massive bodies and active lifestyles. A single adult sauropod, those long-necked giants, like Brontosaurus, might consume over 1,000 pounds of vegetation per day. A large carnivore, like Tyrannosaurus, needs hundreds of pounds of meat regularly to maintain its strength and health. These creatures have evolved during 160 million years of generally stable climate and abundant plant growth. They have no behavioral adaptations for dealing with widespread food scarcity, no instinct to store food for lean times, no ability to hibernate through periods of environmental stress. By late afternoon of that first day, the temperature swings are becoming extreme and unpredictable. The initial heating from falling debris is giving way to something much more ominous, the beginning of what scientists now call impact winter. The shroud of dust, ash, and sulfuric acid droplets surrounding the planet is reflecting more and more sunlight back to space before it can warm the Earth's surface. Our Triceratops, her massive body, designed for the warm, stable Cretaceous climate, begins to feel a chill she has never experienced in her life. Her kind evolved in a world without winter, a planet where palm trees grew at the poles and tropical conditions extended nearly to the Arctic Circle. The concept of sustained cold is as foreign to her physiology as the concept of breathing underwater. She has no behavioral adaptations for preserving warmth. She doesn't know to seek shelter from cold wind, doesn't understand the concept of huddling with others for warmth, has no instinct to find protected areas where body heat can be conserved. Her large size, which has been an advantage in the warm Cretaceous world, helping her reach high vegetation and intimidate predators, now becomes a liability as her enormous body loses heat faster than her metabolism can replace it. She continues to graze, but the plants around her are already beginning to change. Leaves that should be lush and green in this eternal summer world are starting to droop and wither as photosynthesis slows and then stops altogether. The magnolia tree she was eating from this morning already looks stressed, its large leaves curling at the edges and dropping to the ground. High above, the Quetzalcoatlus faces her own crisis. Her enormous wings, magnificent sails that allow her to soar for hours without flapping, require specific atmospheric conditions to work effectively. She depends on thermal updrafts, columns of rising warm air created by solar heating of the ground, to gain altitude and maintain flight. But as the sun grows dimmer and the ground temperature begins to drop, these thermal updrafts weaken and disappear. The predictable air currents she has relied on her entire life become chaotic and unreliable. Her species has perfected the art of soaring flight over millions of years, but now the very physics of flight are working against her. She tries desperately to find rising air, spiraling in tight circles over areas that should produce thermals, but the heating that creates these invisible columns of lift is disappearing as less and less solar energy reaches the ground. Her massive size, perfectly adapted for efficient soaring in the warm Cretaceous atmosphere, now requires more energy to maintain than the changed conditions can provide. But perhaps the most tragic aspect of this day is how normal it still seems to many of its inhabitants. Life has existed on Earth for over 3.5 billion years. For most of that time, it has faced challenges and adapted, evolved new strategies, found ways to survive. Volcanoes have erupted, climates have shifted, ice ages have come and gone, continents have drifted, seas have risen and fallen. Through it all, life has persisted, found new niches, bounced back from adversity with remarkable resilience. So when a young Edmontosaurus, a duck-billed herbivore about the size of a city bus, wakes from her afternoon nap in what will one day be North Dakota, to find the world slightly dimmer and cooler than it was this morning, she's not immediately alarmed. Strange weather happens sometimes. Volcanic eruptions somewhere far away can change atmospheric conditions temporarily. Seasonal variations can bring unexpected temperature swings. Her ancestors have survived countless such events over millions of years. She goes about her evening routine with the patient persistence that has characterized her kind for millions of years. She calls to her herd with musical honks and bellows and sounds that carry for miles across the changing landscape, maintaining contact with family members scattered across their vast feeding grounds. Her distinctive crest, hollow and resonant, acts like a living trumpet, allowing her to produce a wide range of tones and calls. She browses on whatever vegetation she can find as the light continues to fade unnaturally early. Her sophisticated dental battery, hundreds of tiny teeth arranged in grinding surfaces that can process the toughest plant material, works methodically on the increasingly scarce green vegetation. She doesn't understand that she's living through the end of an era. How could she? From her perspective, this is just another day, albeit a strange one. But as night falls on this Tuesday 66 million years ago, the strangeness becomes undeniable. The night sky, which should be brilliant with stars in this world without light pollution, remains eerily glowing. The debris that rained down earlier has heated the atmosphere so thoroughly that the very air continues to radiate heat, like the dying coals of a massive fire. It's neither fully day nor fully night. Instead, it's something unprecedented in Earth's history, a twilight that has no end. This unnatural twilight creates confusion among creatures whose entire life cycles are built around the predictable rhythm of day and night. Nocturnal animals, emerging from their hiding places, expecting the cool darkness they've evolved to exploit, find themselves in a world of strange, orange-tinted light and uncomfortable warmth. Diurnal creatures, expecting the comfort of true darkness after a day of activity, cannot settle into their normal resting patterns. The temperature swings become more extreme and unpredictable as the hours pass. The heated atmosphere from the impact begins to cool rapidly as the sun's energy is increasingly blocked by the thickening atmospheric shroud. In some places, the temperature drops 40 degrees in a single hour for rate of change that most large-bodied creatures simply cannot adapt to quickly enough. But it's not just the rate of change that's deadly mighty, it's the absolute temperatures themselves. Regions that have enjoyed tropical or subtropical climates for millions of years suddenly experience something their inhabitants have no name for: freezing. Water begins to turn solid in places where it has been liquid for geological ages. Ice forms on the surfaces of ponds and streams in equatorial regions, where the very concept of frozen water is as alien as the concept of breathing vacuum. Our little mammalian ancestor, safely tucked in her underground burrow, experiences much more stable temperatures than the chaos above. Soil is an excellent insulator, protecting her from the wild temperature swings happening on the surface. Just a few feet below ground, the temperature remains relatively constant, buffered by the thermal mass of the Earth itself. Her small size, which might seem like a disadvantage in a world of giants, now becomes a crucial asset. Small bodies have higher surface area to volume ratios, which usually makes temperature regulation more difficult, but they also require much less total energy to maintain. While a triceratops needs hundreds of pounds of vegetation per day, our ancestral mammal can survive on a few ounces of seeds, nuts, and insects. Her fur provides insulation that the scaly skin of dinosaurs cannot match. Each hair is a tiny tube filled with air, creating countless small pockets of insulation around her body. This simple adaptation, which evolved originally to help mammals stay warm during cool nights, now becomes the difference between life and death as global temperatures plummet. Her ability to eat almost anything, plants, insects, small animals, even scavenged meat when necessary, means she can adapt to rapidly changing food sources. While specialized herbivores starve as their preferred plants die, and carnivores weaken as their prey disappears, she can switch from seeds to grubs to carrion as circumstances require. Most importantly, her ancestors evolved behavioral patterns that serve her well in this crisis. For 50 million years, mammals have been cautious, secretive creatures. They cache food in hidden locations, create multiple bolt holes and escape routes, remain alert to danger at all times. These behaviors, refined by countless generations of living in a dangerous world, now become survival tools for the greatest catastrophe in Earth's history, the Riviera. Meanwhile, the Triceratops stands in her rapidly changing world. Her massive body, once perfectly adapted to her environment, now becoming a fatal liability. Large bodies are excellent for storing heat in stable conditions, but they're also excellent for losing it when environmental conditions change rapidly. Her huge bulk, evolved for a world of plenty and stable warmth, cannot adapt quickly enough to these unprecedented conditions. She's not alone in her struggle. Across the planet, every large creature is facing the same fundamental crisis. The towering sauropods dinosaurs, so large that their hearts had to work like hydraulic pumps to get blood to their heads 40 feet above the ground, find their massive size working against them. Their necks, evolved to reach vegetation high in the forest canopy, now require enormous amounts of energy to maintain circulation as their metabolisms struggle with the changing conditions. The fierce predators, like Tyrannosaurus, with their enormous energy needs and highly specialized hunting techniques, discover that their prey is becoming scarce and their own bodies are failing them in this new harsh world. A Tyrannosaurus might require 500 pounds of meat per day to maintain its massive frame and powerful muscles as herbivores weaken and die. And as the cold slows the movements of cold-blooded creatures, even the most successful predators find themselves facing starvation. But it's not just the cold that's killing them. As the global shroud continues to thicken, blocking more and more sunlight from reaching Earth's surface. Plants begin to die en masse, not just wither or go dormant, die completely. Without sufficient light for photosynthesis, they simply cannot produce the energy they need to survive. The foundation of every food chain on Earth, the conversion of sunlight into chemical energy through photosynthesis, begins to collapse catastrophically. Imagine trying to survive if every farm, every garden, every forest on Earth suddenly stopped producing food. That's essentially what's happening to the dinosaurs and every other creature that depends directly or indirectly on plant life. The herbivores, from the massive sauropods to our triceratops, find less and less to eat with each passing day. The carnivores, dependent on the herbivores, soon face starvation as their prey weakens and dies. In the oceans, the catastrophe is just as severe, though it unfolds somewhat differently. The marine realm has always been more stable than terrestrial environments. Water has a much higher heat capacity than air, so ocean temperatures change more slowly. Many marine creatures initially seem to weather the crisis better than their land-dwelling relatives. But the ocean food webs depend just as completely on photosynthesis as terrestrial ecosystems do. Microscopic algae, the phytoplankton that drift in the upper layers of the ocean, were the foundation of all marine life. These tiny organisms, invisible to the naked eye, but present in numbers that dwarf all other life on Earth, are the primary producers that convert sunlight and carbon dioxide into the organic compounds that feed everything else in the sea. As sunlight fails to penetrate the darkened atmosphere and reach the ocean's surface, these microscopic plants begin to die in numbers that stagger the imagination. The clear blue waters that have characterized the Cretaceous oceans begin to turn brown and lifeless as billions upon billions of tiny organisms perish and sink to the sea floor. Tiny sea creatures that have fed on these algae for millions of years suddenly have nothing to eat. The small fish and crustaceans that fed on the tiny creatures, in turn, begin to starve. Larger creatures that fed on them face the same fate, and so on up the food chain in a cascade of extinction that reaches from the smallest plankton to the largest marine predators. The great marine reptiles, the mosasaurs that ruled the oceans like aquatic dragons, reaching lengths of 50 feet and more, pits suddenly find their food sources disappearing. These magnificent predators, which have dominated marine ecosystems for over 20 million years, are adapted for a world of abundance. They have no behavioral strategies for dealing with widespread scarcity. The long-necked plesiosaurs, some with necks longer than their entire bodies, specialized for hunting in the rich plankton communities of the open ocean, watch their prey disappear as the base of the food web collapses. Their elegant forms, perfectly adapted for efficient swimming and precision hunting, become useless in a world where there is simply nothing left to hunt. Even the ammonites, those coiled shell creatures related to modern squid and octopuses, finally meet their match in this global catastrophe. These remarkable animals have survived countless earlier mass extinctions over hundreds of millions of years. They've weathered ice ages, volcanic catastrophes, sea level changes, and climate shifts that eliminated countless other species. Their shells have been found in rocks spanning nearly 350 million years of Earth's history. But this time is different. This time, the very foundation of ocean life is collapsing so completely and so rapidly that even these ultimate survivors cannot adapt quickly enough. The ammonites, which have been among Earth's most successful animals for longer than the entire history of life on land, finally face extinction. As days turn to weeks and weeks to months, the death toll becomes staggering beyond comprehension. It's estimated that 75% of all species on Earth go extinct in the aftermath of this single impact. But extinction doesn't happen all at once. It's a gradual process of populations weakening, reproductive rates falling, and entire species slowly fading away like candle flames going out one by one in a growing darkness. Our Triceratops might survive the impact day. Her robust constitution and large body mass might carry her through the first few weeks of the changed world. But as her food sources disappear and the cold deepens, her enormous body becomes impossible to maintain. She grows weaker with each passing day, her movements slower, her ability to find and process food increasingly compromised. Eventually, perhaps a month or two after that terrible Tuesday, she lies down in a place that will become a fossil bed, a quiet grove beside what was once a flowing stream, but is now a frozen ribbon of ice. She doesn't get up again. Her massive skull, with its distinctive three horns and bony frill, settles into the sediment that will preserve her form for 66 million years, until human paleontologists uncover her remains and piece together the story of her world's end. The Quetzalcoatlus faces a similar fate, though perhaps more quickly. As the skies remain turbulent and prey becomes scarce, her enormous size, once her greatest advantage, becomes a fatal burden. She needs too much food to maintain her massive body, requires too much energy to stay aloft in the chaotic atmosphere. Her last flight might be a desperate search for thermal updrafts that no longer exist, spiraling lower and lower until she can no longer gain altitude. One day, she simply cannot generate enough lift to become airborne again. Her magnificent wings, which once carried her across continents with effortless grace, fold for the final time. But remember our small furry ancestor? She continues to survive in her underground refuge, emerging only when absolutely necessary to find food. Her small size means she needs very little to sustain herself. Her generalist diet allows her to exploit whatever resources remain available. Her burrow protects her from the temperature extremes and provides a stable microenvironment while the world above transforms. She's not the only survivor, of course. Life is remarkably tenacious, and even a catastrophe of this magnitude cannot eliminate it entirely. Some dinosaurs do make it through the crisis, though not the giant forms we typically think of. Small, feathered creatures, the direct ancestors of modern birds, manage to survive in small numbers, scattered across the globe. Their feathers provide insulation against the cold that scaly skin cannot match. Their small size reduces their food requirements to manageable levels. Their ability to fly allows them to seek out the scattered resources that remain available across the devastated landscape. Most importantly, many of them have behavioral adaptations that serve them well in the crisis, the ability to migrate to more favorable conditions, to form flocks for warmth and protection, to eat a wide variety of foods as circumstances require. Crocodiles and turtles, with their slower metabolisms and remarkable ability to go long periods without food, weather the crisis better than most reptiles. Their cold-blooded physiology, often seen as primitive compared to the active, warm-blooded lifestyles of dinosaurs and mammals, now becomes an advantage. They can slow their metabolism to near hibernation levels, surviving on stored body fat when food becomes unavailable. Some fish survive in lakes and rivers that don't freeze solid, though many aquatic ecosystems collapse as completely as terrestrial ones. Certain plants manage to persist as seeds or spores, waiting out the catastrophe in dormancy until conditions improve enough for growth to resume. But for every survivor, there are dozens of casualties. For every lineage that manages to persist through the crisis, there are many more that simply vanish forever, leaving only their fossilized remains as testimony to their existence. The recovery, when it finally comes, takes an almost unimaginably long time. For months, perhaps even years, the earth remains shrouded in darkness. The impact winter persists as dust and debris slowly settle out of the atmosphere and the sulfuric acid droplets finally condense and fall as acid rain. The planet's surface remains cold and largely lifeless, a frozen wasteland where once lush forests stood. Slowly, very slowly, the atmospheric shroud begins to clear. Dust settles to the ground, acid droplets fall as rain, and bit by bit, sunlight returns to Earth's surface. The process is gradual, not a sudden lifting of darkness, but a slow brightening that takes place over months and years. The first plants to recover are those that survived as seeds or spores in the soil. Ferns, those ancient and resilient plants that have survived countless catastrophes over hundreds of millions of years, are among the first to emerge. Their spores can remain viable in the soil for years, waiting for conditions suitable for growth. Slowly, very slowly, photosynthesis resumes on a global scale. The few surviving plants begin to grow again, producing the oxygen and organic compounds that will support the recovery of animal life. But the ecosystems that emerge from this catastrophe are profoundly different from those that existed before. The ecological niches left empty by the dinosaurs, the role of large herbivore, large carnivore, forest canopy dweller, apex predator, remain vacant for millions of years. The surviving fauna consists mainly of small creatures, mammals no larger than cats, birds about the size of modern crows, reptiles that could fit in your hand. But nature, as they say, abhors a vacuum. Over millions of generations, the descendants of these small survivors begin to diversify and grow larger, exploiting the opportunities left by the dinosaurs' disappearance. Our small furry survivor and her descendants emerge from their burrows into a world made new, with no giant dinosaurs to compete with, no massive predators to hide from. The mammalian lineages begin an adaptive radiation that will eventually produce the incredible diversity of mammals we see today. Some of her descendants become grazers on the recovering grasslands, developing the adaptations that will eventually characterize horses, deer, cattle, and countless other herbivorous mammals. Others become predators, evolving the keen senses and powerful muscles that will define the carnivorous lineages, the ancestors of cats and dogs and bears and wolves. Still others take to the trees as forests slowly recover, developing the grasping hands and forward-facing eyes that will eventually characterize the primate lineage, our lineage. The same environmental pressures that drove these early mammals into the trees, the need to exploit new food sources and escape ground-dwelling predators, will eventually lead to larger brains, more complex problem-solving abilities, and the kind of intelligence that allows for tool use, language, and ultimately the capacity to understand and tell the story of the catastrophe that made our existence possible. The descendants of the surviving birds diversify as well, though more slowly than the mammals. Without the giant pterosaurs to compete with, they gradually expand into new ecological niches. Some become the large flightless predators that will dominate terrestrial ecosystems for millions of years. Birds like the massive eagle-beaked Gastornis, standing 8 feet tall and weighing 400 pounds. Others remain small and agile, evolving the incredible diversity of song, flight, and feeding strategies that characterize modern birds. The melodious calls that greet each dawn in your modern world are the evolutionary descendants of the survival songs of creatures that lived through the end of the dinosaurs. The recovery of marine ecosystems follows its own timeline. With the great marine reptiles gone, new groups begin to exploit the oceanic realm. Early whales, unjuices, small otter-like creatures that lived along coastlines, gradually adapt to fully aquatic life, eventually growing to sizes that rival the largest dinosaurs. Fish lineages that survived the catastrophe diversify into forms that fill the ecological roles once occupied by marine reptiles. Sharks, those ancient and supremely successful predators, continue their evolutionary refinement, adapting to the changing ocean conditions with a flexibility that has made them one of life's most enduring success stories. The ammonites are gone forever, but their ecological niche is gradually filled by other cephalopods, the ancestors of modern squid and octopuses, which develop intelligence and adaptability that rivals that of many vertebrates. But perhaps most remarkably, the impact itself becomes part of the geological record, a thin layer of clay and rare metals that can be found in rocks around the world. This layer, known as the KPG boundary, contains unusually high concentrations of iridium mins, a metal that's rare in Earth's crust but common in asteroids. Decades of detective work by geologists and paleontologists have allowed scientists to piece together the story of that Tuesday 66 million years ago with remarkable precision. The evidence is written in the rocks themselves, shocked quartz crystals that could only have formed under the extreme pressures of an impact, tiny spherules of glass created by the condensation of vaporized rock, layers of soot from the global wildfires. The story told by these rocks is one of almost unimaginable catastrophe, followed by gradual recovery and explosive diversification. It's a reminder that Earth's history is punctuated by events so dramatic that they completely reset the evolutionary clock, creating opportunities for new forms of life to emerge and flourish. The asteroid impact that ended the age of dinosaurs also began the age of mammals. Without that catastrophic Tuesday, 66 million years ago, the small nocturnal creatures that were our ancestors might never have had the opportunity to emerge from the shadows and diversify into the incredible variety of mammalian life that exists today. The evolutionary pressures that drove early mammals to develop larger brains, more complex social behaviors, and eventually consciousness itself might never have occurred if the dinosaurs had continued to dominate terrestrial ecosystems. The intelligence that allows you to understand this story, the curiosity that drives scientific investigation, the capacity for wonder that makes you marvel at the deep history of life on Earth. All of these quintessentially human traits might never have evolved without the catastrophe that ended the Mesozoic era. In a very real and profound sense, you exist because of that asteroid. This is one of the most remarkable realizations in all of science, that the catastrophe that ended one chapter of life's story also began another. The death of the dinosaurs was not just an ending, but a beginning. It's a reminder that life is both incredibly fragile and incredibly resilient, that extinction and evolution are two sides of the same cosmic coin, that endings and beginnings are often the same event viewed from different perspectives. As you lie there in your comfortable bed, warm and safe in the modern world, consider the profound depth of time that connects you to that small mammalian ancestor hiding in her burrow 66 million years ago. Through countless ice ages and volcanic eruptions, climate changes and continental drifts, meteor strikes and mass extinctions, an unbroken chain of survival connects you to that Tuesday that changed everything. Every breath you take contains oxygen produced by the photosynthesis that gradually returned to our planet after the impact winter ended. Every beat of your heart continues a rhythm that began in creatures who learned to survive in the darkness after the lights went out. Every thought you think happens in a brain that evolved from ancestors who were smart enough, or lucky enough, or brave enough to endure when giants fell. The neural pathways that allow you to process language, to form memories, to experience emotions, to imagine futures, and remember pasts, but all of these are the products of evolutionary processes that began with survivors of the greatest catastrophe in Earth's history. The very capacity for consciousness that allows you to contemplate your place in the universe arose from lineages that persisted through the end of worlds. Your hands, with their opposable thumbs and sensitive fingertips, evolved from paws that once scrabbled for seeds in the ruins of a destroyed world. Your eyes, capable of perceiving beauty and wonder in everything from a sunset to a mathematical equation, developed from organs that once peered fearfully from burrows into a landscape transformed by cosmic violence. Even your capacity for empathy, through your ability to care about creatures separated from you by vast gulfs of time and evolutionary distance, springs from the same fundamental drives that helped your ancestors survive by caring for their offspring, cooperating with their kin, and maintaining the social bonds that made survival possible in the harsh world that followed the impact. The last day of the dinosaurs was not really an end in the lay, it was a transformation. Life didn't stop. It changed direction with dramatic suddenness. Evolution didn't cease. It found new pathways through landscapes of possibility that had never existed before. The story didn't conclude. It began a new chapter that would eventually lead to creatures capable of understanding their own history. And that new chapter led, through countless generations and countless adaptations, through the rise and fall of ice ages, through the slow dance of continents across the globe, through the emergence of grasses and flowers and forests, through the evolution of intelligence and consciousness and wonder, to this moment. To you, listening to this story in the quiet comfort of your evening, safely warm and comfortable, connected to creatures who lived 66 million years ago through an unbroken chain of survival, growth, and adaptation that spans more time than the human mind can truly comprehend. In the quiet of your evening, as your breathing deepens and your thoughts begin to drift towards sleep, you might imagine that small mammalian ancestor of ours, emerging from her burrow into a world made strange and new by forces beyond her understanding. She doesn't know she's a survivor of the greatest catastrophe in life's history. She doesn't know her descendants will one day walk upright, build cities, explore space, split atoms, decode the secrets of heredity, and tell stories about the day the sky caught fire. She just knows she's alive. In a world transformed by cosmic accident into something alien and hostile, she's still breathing, still heartbeat by heartbeat continuing the ancient rhythm of existence. And in her survival, in her persistence, in her quiet refusal to surrender to catastrophe, lies the seed of everything that follows. Every flower that bloomed in the recovering world carried genes passed down from plants that survived the impact winter. Every song that filled the air, as birds re-diversified, carried melodies inherited from survivors of the great dying. Every innovation in the long journey toward consciousness built upon foundations laid by creatures that endured when everything familiar disappeared. The forests that grew back from the ashes were not the same forests that burned. The creatures that filled the recovering world were not the same creatures that perished, but they were connected to those earlier forms by the unbreakable threads of inheritance, by the persistence of life itself through the greatest test it has ever faced. Tonight, wherever you are in the world, whether you're listening from a bustling city where millions of lights push back the darkness, or from a quiet countryside where you can still see the stars that witness that ancient catastrophe, you are part of that continuing story. Your existence is proof that life finds a way, that catastrophe can become creation, that endings can become beginnings, that destruction and renewal are partners in the long dance of evolution. In your warmth and comfort and safety, you embody the ultimate victory of life over destruction, of persistence over catastrophe, of hope over despair. The dinosaurs' last day was 66 million years ago, but their story didn't really end. It transformed in ways that no creature living on that Tuesday could have imagined. The birds singing outside your window tomorrow morning will carry dinosaur songs in their throats, melodies evolved from calls that once echoed across Cretaceous landscapes. The flowers blooming in gardens around the world carry in their DNA the memory of ancient forests that once fed giants. Even the soil beneath our feet contains recycled atoms from creatures that lived through that terrible, wonderful, world-changing Tuesday. The carbon in your body, the calcium in your bones, the iron in your blood, all of it has been cycling through the Earth system for billions of years, and some of it was once part of creatures that witnessed the end of the dinosaurs. In the most literal sense, you are made of stardust and ancient life, of elements forged in the hearts of dying stars, and atoms that once formed the bodies of creatures whose world ended so that yours could begin. The very substance of your being connects you to that Tuesday 66 million years ago and to every day since in an unbroken chain of material and energy that stretches from the impact to this moment. So as you drift toward sleep, carried by the rhythm of your own heartbeat, that ancient percussion that has been beating in the chests of our ancestors since before the first flower bloomed, since before the first mammal emerged from hiding, since before the sky caught fire and the world changed forever. Remember that you are part of life's greatest story. You are the descendant of survivors, the inheritor of persistence, the continuation of a tale that began in darkness and catastrophe and led to light and consciousness and wonder. You are the living proof that life not only endures, but triumphs, not only survives, but creates beauty and meaning and understanding from the raw materials of existence. In your dreams tonight, you might find yourself walking through Cretaceous forests under warm skies, watching gentle giants go about their daily lives in a world about to end. You might feel the earth shake with the tremors of cosmic impact, see the sky catch fire with falling stars, witness the transformation of a world. But remember, as you explore these ancient landscapes in your dreams, that you are not just an observer of this history, you are its outcome, its culmination, its meaning made manifest. The capacity for wonder that allows you to marvel at deep time, the curiosity that drives you to understand the past, the empathy that makes you care about creatures separated from you by vast gulfs of time. These are the gifts bequeathed to you by survivors of the greatest catastrophe in Earth's history. Sweet dreams, fellow survivor. Sleep well, knowing that the same indomitable force that carried our ancestors through the darkness after the asteroid will carry you safely through this night and into tomorrow's dawn. Rest peacefully in the knowledge that you are part of an unbroken chain of persistence that stretches back to the very beginning of life on Earth and forward to futures we can barely imagine. Thank you for joining me on Sleep About Science tonight. If you enjoyed this journey to the last day of the dinosaurs, I'd love to know where you're listening from and what moments from deep time you find most fascinating. Perhaps you have questions about the creatures that survived, or wonder about other mass extinctions in Earth's history, or are curious about how scientists piece together these ancient stories from rocks and fossils. Until next time, wherever you are in the world, whether you're drifting off in the gentle darkness of evening or finding peaceful moments in the busy light of day, may you sleep soundly and dream deeply of the extraordinary story of which you are a living, breathing, thinking part. Good night, and remember, you are the universe becoming aware of itself, the product of 13.8 billion years of cosmic evolution, the descendant of stars and survivors, the continuation of a story that began with the Big Bang and continues with every beat of your heart. Sleep well, fellow traveler through time and space. The same stars that shone down on that Tuesday 66 million years ago are still shining tonight, and you are here to see them because life found a way to endure, to persist, to triumph over even the greatest catastrophes that the universe could devise. Sweet dreams.